Okay, let me give you a refresher on solving a proportion. Okay, and that's what we have up here. Okay, and just a reminder, a proportion is an equation that states that two ratios are equal. Okay, so we have a ratio of 6/8 equal to a ratio of 7/A, where we don't know what A is. Okay, so we're going to solve for A in this proportion. Okay, we're going to do the cross multiplying idea here. You could also use the standard approach to solving the equation, and you could still get to this. Okay, you have to be careful with that when you have a variable in the denominator, but it does work. Okay. Okay, so in this case, we're going to multiply diagonally. Okay, I'm going to multiply both ways diagonally. Then I can come back and show you how to take one step out of this because of the proper, or because of this way to do it. So we're going to do 8 times 7 on one side equals 6 times A on the other. Excuse me. So 8 times 7 is 56. Okay, and 6 times A is 6A. And then we know that we know we want to get A by itself, we're going to divide by 6 on both sides. Okay, so A equals, A equals 56/6. I know that both of them divide by 2. The top one's going to be 28. And the bottom one's going to be 3. 56 divided by 2 is 28. So let's see, that is, yep, that's right. And 6 divided by 2 is 3. So 28/3. Or we can then say, how many times does 3 go into 28? Just turned out to be pretty nice. Okay. Maybe not. It goes in 9 times. That's 27, right? And then there's 1 left over. 9 times 9 is, or 9 plus 9 is 18. Plus 9 is 27. And then we have, well, 27. 9 and 1/3. Start saying the number, and then you want to write it down. Okay, 9 and 1/3 is another way to write that. Okay. Okay, let's look at, let me rewrite this down here. 6/8 equals 7/A. 6/8 equals 7/A. Let's solve this using, okay, that was cross multiplying. Now let's cross multiply dividing. So we're going to cross multiply here. So since our variable's in this corner, we're going to cross multiply diagonally across it. Okay, and then we're going to divide by the number that's left. We're going to divide by the number that's left. Okay, so it just depends on where your variable is, but as you'll see, this is the exact same steps we took up here. It just kind of saves us from writing down one of the steps. Okay, because we did 8 times 7, and then we ended up taking 8 times 7 and dividing it by 6. So this just kind of saves you one step. Okay, so 8 times 7/6. Okay, and as you can tell, this just gets us right back to where we were. Okay, which should end up being 28/3. Okay, we can also 6/8 equals 7/A. Okay, we can also use standard algebra to solve these. So this would be the third method for that. Now, the one thing that's weird, like I said before, is that this time the variable is in the denominator, and we can't solve it while it stays in the denominator. So it is currently dividing, okay, the 7 is being divided by the A. Okay, so if this was a number, our rules would say to take that number and do the opposite operation on it. Okay, so if we were dividing by 6, we would multiply by 6 on both sides. Okay, so since we'll just treat it like it's a number. Okay, so that's we're dividing by a. Let's multiply by a on both sides. Okay, and since these are fractions, if you want, you can multiply by a over 1. And now we can think, well, I have an a in the denominator and an a in the numerator, so those have to cancel. And over here, I don't have that. Okay, so I'm going to multiply straight across. 6 times a is 6a. 8 times 1 is 8. And this equals 7 over 1, which is 7. And now it does look like an equation. Okay? And now we'll use that other rule. Dividing by 8 over here, so let's multiply by 8. Or 8 over 1. Since that side's a fraction, I can write 8 like it's a fraction. Now the numerator 8 and the denominator 8 cancel, leaving me with a 6a equals 7 times 8, which is 56. And predictably, this looks almost identical to what we've done on the other two problems. Okay, and now I have 6a, so I want to get rid of the 6. So I divide by 6 on both sides, and 56 over 6 is 28 thirds. So 3 different methods that are almost the same method that will all work. Okay. Now, one note I want to make is that when you decide to do either the top two, so cross multiply or cross multiply divide, one thing that some students get hung up on is this situation. They'll get cross multiplying confused with the multiplication of two fractions. So sometimes students will say, I've got two fractions multiplied by each other, so I'm going to cross multiply them, which is incorrect. Okay? So don't get this whole, it's actually kind of a trick method. The cross multiply divide or the cross multiplication. Don't get that confused with normal rational multiplication or fractions that you multiply. Okay? Remember, when you multiply fractions, you're going to multiply straight across. Okay? Not cross multiply them. Okay, here's an example of scale factor or scales and how they can be used with a ratio. Okay. So this one says the blueprint for a house states that 2.5 inches equals 10 feet. If the length of one actual wall in the house is 12 feet, how long is the wall in the blueprint? Okay. Well, there's a few different ways to set up these equations. I really like the idea of taking the scale drawing, which would be the blueprint in this case, scale drawing, and putting its number out there, 2.5 inches, or 2.5, I guess it doesn't matter if we have that label on there for right now. Then we can put inch there. And then I'm going to put the actual measurement for the drawing. Okay, so we drew, the scale on the blueprint says that if you measure 2.5 inches, in actuality it should be 10 feet in real life, like if you went to the job site. Okay, so in this case I've got 2.5 inches for the scale. I'm going to put the actual down as 10 feet. Okay, and then this allows me to easily set up a proportion. I just have to make sure that I do it in the same manner. I need to put scale over actual again. Okay? So the scale drawing is actually what we're looking for here. How long is the wall in the blueprint? That would be the scale. Well, we don't know. Okay? We can put wall in the blueprint. Okay? Because we don't know what it is. So I put a W there. So that's the length of the wall. We could put L. Okay? Whatever variable you want to use there. Okay? How big is that wall in actuality? Well, it's 12 feet. It's 12 feet long. So we'll put the 12 feet down below in the denominator because that's where we put the actual length in the other ratio. Okay? So now all we have to do, well, we can use any of those methods we just used. Okay? The easiest is cross multiply divide. So cross multiply and then divide by this number. because our variable is here. Okay, so, well, let's write that out. 2.5 times 12 divided by 10. Okay, and I'll talk dimensional analysis in just a minute with this. There's common sense way to come up with what your dimensions should be or what your label should be on your final product, and then there's dimensional analysis, which can tell you what it's supposed to be. And that dimensional analysis is really nice, especially in science classes. So we'll get to that. 2 times 12 is 24, plus half of 12 is 6. Okay, so that should be 30 in the numerator. So in this case, W is 3. And since we were looking for the length of the wall in the drawing, well, the rest of the drawing is in inches, so this better be in inches. Okay? W is 3 inches. Now, how does that work? Well, let's come back. Let's take this equation and bring it over here. We have 2.5 inches times 12 feet. Okay? Over, I'm going to run out of little space here. Let's put this arrow and slide this baby over. Okay? Over 10 feet equals W. This is called dimensional analysis. It's not that huge of an idea, or that huge of an issue if you don't remember what it's called. It is a nice thing to do. Let's treat the labels on this as if they were numbers that you can divide or multiply. Okay, so in this case, we have a feet in the numerator and a feet in the denominator. So I would, well, you would, on a normal problem, say, I'm going to cancel those. So those are gone. Okay, so now we have 2.5 inches times 12 divided by 10, and there's only the label of inches left. Okay, that's called dimensional analysis. You basically treat your variables, your labels, as if they were variables. You could call them that, yeah, kind of treat them like they're variables. You treat them like they're the part of the number, okay, or one of the numbers in there. Okay, and now we know how this problem finishes because 2.5 times 12 is 30, and it has the label of inches on it, over 10 equals W. So we have 3 inches. Okay, so there's kind of this idea that you can go through the problem and then decide what your label is. And most of the time, especially in math, with proportions when we're talking about scale, it should be pretty simple to figure out. Well, I'm talking about the length on the drawing, so it should be in inches. If I was talking about the actual length, it should probably be in feet. Okay? But dimensional analysis, this method over here, okay, is a way that will tell you what your label should be. Okay, as long as you do it correctly, it should tell you exactly what your label should be at the end. There should be no thinking about it. Okay, so that's a review on ratios, I guess, proportions, and solving scale problems.